Hello students, good morning. Last time we started the lesson number 11, reflection of light. Today we continue the next point, images formed by a concave mirror. See there one activity given for us, material, candle or a glass lamp, 2 cardboard boxes, then one large cardboard sheet, white paper, concave mirror, meter, ruler and wooden block. Action or activity given here, procedure is that take the cardboard box large enough, that is shown in the figure, to hold the candle or lamp. Cut off one side and place the candle inside. Cut out an arrow shaped slit from one side so that we get an arrow shaped light source. Make a screen of size 20 cm by 30 cm by sticking a white paper on the cardboard sheet and set it up vertically with the help of wooden block. Fix the mirror vertically on the other cardboard box by making a slit on its top surface. So image is formed by a plane mirror. Which mirror is used here? Plane mirror, but actually we are not using plane mirror here. So we are using concave mirror. Now place a screen, see there in figure simultaneously. Place the screen near a window and place the mirror in front of it such that the image of the sun or some far away object forms clearly on the screen. Measure the distance between the screen and the mirror in this situation. Which distance we measure? Distance between screen, where the clear image is obtained, and the mirror, the distance between screen and mirror. That distance is called as what? Focal length of the given mirror. Now set up the experiment as shown in the figure in a dark room. Place the mirror near the 0 mark on the meter scale. Place the screen in front of it and place the light source in between the two so that the distance between the mirror and the source is little more than the focal length of the mirror. Obtain a clear image of the source on the screen by moving the screen along the meter scale and perpendicular to it. The image will be inverted and larger than the source. As the image is obtained on the screen, so images obtained on the screen, that images are called as what? Real images. So here real image is formed. Now move the source away from the mirror so that the distance between the two is greater than twice the focal length of the mirror. Get a clear image on the screen by moving it towards the mirror. So the image is inverted, smaller than the object, and that image is obtained on the screen. So again nature is real. So observe here two ray diagrams. For drawing the ray diagrams we are using that 3 rules we learned in previous lecture. So observe in the figure A. Object is a place AB. AB is the object between the C and F. C means center of curvature, F means principal focus, and the center of the mirror MN is a P, that P means nothing but the pole. So line passing through center of curvature C and P means pole, that line is called as principal axis. So where is the position of object AB? Between C and F. So out of that 3 rules we are using any 2 rules and to draw the ray diagram. So first of all, blue color, check that. First incident ray is from point A towards the mirror, that is showing by blue line, that is parallel to principal axis CP, and one more incident ray is passing through the point F, that is the focus, up to the point Q on the mirror. So AQ is the second incident ray and AS is the first incident ray. So AS is a incident ray parallel to principal axis. So what is that rule? When incident ray is parallel to principal axis, its reflection passes through focus. So from the point S, reflection takes place through point F. So SF up to the point R. Clear all of you? This is the first reflected ray. Now second reflection from point Q. So AQ is the incident ray and this is passing through the principal focus. So what is that rule? When incident ray is passing through the focus, reflection occur parallel to the principal axis. So QR is the second reflected ray and that is parallel to principal axis. So both that pink color reflected rays meet at one single point, that point indicated as a A dash. So A dash, so from the point A dash, draw perpendicular line up to the principal axis up to B dash. So A dash B dash is the image. And where is that image formed? After the point C, that is we called as beyond center of curvature, beyond C, outside the center of curvature. Compare the size of AB and A dash B dash. So as compared to AB, A dash B dash is a more in size, that is a more size. So it is a inverted image. A dash is at the bottom point and that's why it is an inverted image. Then it is a magnified, that is a enlarged, that is a more size as compared to AB. So always inverted image is a real image. Clear all of you? Next, really that reflected ray intersect to each other. Next one. Check the position of object AB between principal focus and P means pole. So first incident ray showing by the blue line. Clear? So that is parallel to principal axis, that is up AQ. AQ is the incident ray parallel to principal axis. So reflection takes place through principal focus. So Q, that reflected ray passing in this direction, QF. Here very important is that always you show the arrow. If you are not showing arrow, no meaning for your diagram. Next, second incident ray we are using that third rule, when incident ray passing through the center of curvature, so reflection takes place through the same point in the opposite direction. So point C and A join up to the S. So AS is the incident ray, show the arrow on that incident ray, and then from the point S, that is reflected in this direction, that is SC. Clear? But both the reflected ray are divert from each other. We are extend in a forward direction. They never intersect to each other. That's why we are extending these two reflected ray in opposite direction, that is behind the mirror by dotted line. They are appear to meet. They are looking like meet where behind the mirror at point A dash B A dash, and that's why this image is formed behind the mirror. That's why it is not real. Why? Because reflected ray do not really intersect to each other. We are extending in backward direction. That's why that A dash at point A dash, that reflected ray appear to meet at point A dash, and that's why this image is not real. So this image is called as a virtual image. Size enlarged as compared to AB, that size is greater, and virtual images are not inverted, means that is called as a erect. Not inverted means erect. Clear? Like our body structure, or we are looking like in a plane mirror at home. our image form in a plane mirror, that is the not inverted, that is the erect. All of you getting? So according to different positions, we are studying here about the ray diagram. Two diagrams are given here. Next, see the explanation. As shown in figure 11.11a, an object AB is placed between focus and center of curvature of concave mirror MN. The incident ray AQ, starting from point A and going through the focus F, becomes parallel to principal axis after reflection and returns along QR. The incident ray AS, parallel to principal axis, after reflection passes through the principal focus, and returns along the path ST. It cuts or intersects the reflected ray QR at point A dash. Thus, the image of A is formed at A dash. The point B is situated on the principal axis, and so its image will also be on the axis and will be directly above A dash. Thus, the image of point B is at B dash. The image of points between A dash and B dash will be formed between points A dash and B dash. Thus, the image of object AB is A dash B dash. This is the explanation of that first ray diagram. From this, we see that when the object is placed between the focus and the center of curvature of the mirror, the image is formed beyond the center of curvature. Where is the position of image? Position of image is beyond the center of curvature. This image is a larger size than the object and inverted also. So inverted image is always a real image. Remember, real images always obtained on the screen. Really, the reflected rays intersect to each other, meet to each other, and that's why that image is real, and real images are always inverted. As the reflected ray actually cross each other, see the explanation given here in that line. As the reflected rays actually cross each other, the image is a real image and can be obtained on the screen. All are getting? Yes? Next. Explanation of the figure B. An object AB is placed between the pole and focus of the mirror. The incident ray AQ is parallel to the principal axis, and the incident ray AS is in the direction joining A with the center of curvature. So out of that three rules, you use any two rules and draw the ray diagram. The figure shows how these rays get reflected and form the image A dash B dash of the object. This image is obtained behind the mirror. So that image is erect, means not inverted, and larger size is larger than the object. Remember these 3 points: position of image, size of image, and nature inverted or erect. Clear? As the reflected rays do not actually meet but appear to come together behind the mirror when we are extending that reflected rays in opposite direction. So that image is a virtual image. The position and type of image produced by a concave mirror when an object is placed at a different distances from it are given in the following table. So only 2 ray diagrams given to us on previous page. Which one? The object placed between pole and focus, that is the first one. In table check that. So that image is formed. Position of the image given here behind the mirror. Is it correct? Nature is erect and virtual, and size is what? Magnified. All are getting? All are getting? And one more ray diagram given on the previous page. Which one? The object placed between focus and center of curvature. That is the third one. So position of the image obtained beyond the center of curvature, is it correct? Nature of the image is inverted and real. See that third point. And size of the image is enlarged or magnified. Magnified means enlarged. Getting all of you. So in this way, you do the practice how to draw that ray diagrams as per the position of object by using the 3 rules. I will show the explanation or ray diagrams in this today's lecture also. So 6 different positions are given for the object. So I will explain these positions, and according to position of object, we are getting the same information or not. We are checking here position of image, nature and size of the image. Clear? See. And one more point. Now try this. These 5 lines that is omitted from our syllabus. Clear? But in this table, these positions are given. So as per these 6 positions, we are drawing the ray diagrams. I will show after some time. And last point is, see the theory what is given. Image formed by a convex mirror. Now figure 11 point, see there. Here. Figure 11.12 or 12 shows an object AB kept in front of a convex mirror MN. Check that. Where is shown the object AB? In front of the mirror, because shading is given on right side of the mirror, that is called as the inner side, and that's why it is a convex mirror is formed. Incident rays AQ, check that. In blue line is showing here. That incident ray AQ starting from point A and traveling parallel to principal axis, and AR going towards the center of curvature are shown in the figure. First incident ray is a from the point A to Q. Check here. Show the arrow. Arrow is showing. So incident ray is parallel to principal axis. Reflection takes place through focus. So point Q and F join in a straight line. So our really reflection is like this way. Check here, I will show you. Getting all of you. And third rule we use here. From the point A and C, means this AC is nothing but incident rays passing through center of curvature. So join the point A and C up to mirror dark line, but behind the mirror showing by a dotted line. Clear all of you? All are getting? Yes. So actually reflection is, so we are showing the arrow like this. This is the second incident ray. So reflection takes place through center of curvatures in the same path. No deviation. So these two rays are diverged from each other. That is never intersect in front of the mirror. So extend in a backward direction. Check that. Be carefully with the help of scale pencil. So where is that extended rays behind the mirror intersect at point A dash. So image is formed here. Now check the size of object AB and size of image A dash B dash. Easily we are observing here image size of the image is smaller. See in explanation. So how these get reflected and form the image A dash B dash can be understood from the figure. It is clear that the image is smaller than the object. Yes, all are getting? A dash B dash is smaller than AB. Means AB is the object and A dash B dash is the image. So image is smaller than the object. Where is that image formed? In front of the mirror or up, behind the mirror? So easily we observe in the figure behind the mirror. So image obtained behind the mirror. So it is a virtual image, and virtual image is what? Erect image. That image is not inverted, means erect image, and erect image is a virtual image. As the reflected rays do not actually cross one another, the image is virtual. All are getting the explanation? So the nature of the image formed by a convex mirror does not depend on the distance of the object from the mirror, because in front of the mirror no any point is there. Which point? No principal focus, no center of curvature, because these points on the behind the mirror. Check these points. Clear, all of you? So very important line is given there. The nature of the image formed by convex mirror does not depend on the distance of the object from the mirror. Anywhere you place the object in front of a convex mirror, all are getting? These images are underlined always virtual. The images obtained by a convex mirror are, remember this sentence, underline this sentence. So the images obtained by a convex mirror are always virtual, smaller than the object, and situated behind the mirror. Very important sentences these two. Clear, all of you? Yes, getting? So this is the ray diagram. Try to draw. Now I will explain here the basic concept how to draw the ray diagram. This is the today we finish up to this point, and next point is what? The divergence and convergence of light, that we will continue next time, because I will explaining here basic concept how to draw the ray diagrams. Now see here. First one, object placed between pole and focus. So what you are doing now? See the basic concept. Listen carefully. In your notebook, lines are given. So on one line you draw the principal axis first. That is a CP. The line passing through CP, center of curvature and pole, is called as what? Principal axis. So you draw that line. Then from the point C up to F. Now this check, see there. How to plot this point C and P? Okay, center of mirror is a pole, so that point is a fix. Now on this principal axis, C point is taking at 6 centimeter from the P. What we are taking the distance? From point C, C point is situated from the point P at 6 centimeter. So exactly at half distance, that is at 3 centimeter. Which point is there? Point F. So F point means nothing but what? Clear? First of all, we are drawing this principal axis. Then point P we plot here. From the point P, with the help of scale, we plot the point C, that is center of curvature. And with the help of compass, we are drawing one arc from the point C, that is the mirror, in this way. All are getting? 4 lines above and 4 lines below. Like that you draw the mirror and show these lines also like this. Clear? Next, exactly at half distance means up to 3 centimeter. Which point is there? Principal focus. Now what is the first position? Position of the object placed between pole and focus. So we are showing the object of one line only. Remember, this is a basic concept. Labeled it AB. Now draw first incident rays parallel to principal axis, so reflection takes place through the focus. You are show the arrows, that is very important. And second incident rays directly passing through center of curvature, so straight line up to the mirror and then extend in a backward direction. These two reflected rays divert from each other, not meet to each other, so extending in a backward direction by dotted line. So they appear to meet at one point, that is A dash and B dash. Image is formed behind the mirror. Image formed behind the mirror means nature is erect and virtual. Erect and virtual. And check the size of the image is magnified. So you write down these 3 points: position, size, and nature of the image below the diagram. Clear, all of you? Next. Object at focus. Check now. I will show the explanation. All arrows and all arrays are shown in the figure. So object at focus. So AB. First incident ray is parallel to principal axis. So incident ray parallel to principal axis, reflection takes place through the focus. That basic concept is same. You draw one principal axis point from the point P, take a point C, that is center of curvature, at 6 centimeter, and half distance means at 3 centimeter, plot the point F, that is a principal focus. This is a very basic concept. And second incident ray is passing through the center of curvature. So A and C directly join in a straight line. Incident ray and reflected ray in opposite manner. So reflected rays are parallel to each other. So where is image form? At infinity. Size very large and nature inverted and real. Clear? Next. Third one. Object place. Check the explanation. Object place between focus and center of curvature. Between center of curvature and focus. So what I am telling, only one line object we are showing in these first three diagrams. You remember the position and what we are taking the size of the object. If you are taking more size, so see there, my image is also from outside the margin. So your images are from outside the page also. So this mirror we are shifting slightly. Remember this position, object placed between focus and center of curvature. So instead of this position, we are drawing the mirror slightly on the right hand side of the page, especially in this position, in this third case. Clear all of you? So first incident ray parallel to principal axis. After reflection, it is passing through the focus. And second incident ray is passing through center of curvature. Point C is available. So A and C join like this way towards the mirror incident ray and in the opposite path, opposite direction. So where is intersection? So image is formed at this point, A dash B dash. So position of the image is beyond C. See here, point C is here. So object between C and F. Clear? Object is here. So image is formed beyond the center of curvature. Size is magnified. Magnified means enlarged. And nature is inverted and real. These are the third diagram. Next, fourth one. Object placed between, object placed at center of curvature. Check now. So object at center of curvature. Now from this fourth ray diagram, take the object of two lines. So first incident ray is parallel to principal axis. Reflection takes place through focus. Second incident ray is passing through the focus. Reflected ray parallel to principal axis. Where is the intersection occurs? So there is image form. So position of image at same center of curvature. Size is same side. Check that. Object is of two lines. Image is also of two lines. And nature is real and inverted. Next, fifth one. Object beyond the center of curvature. So where is the point C? Is here. So object beyond center of curvature, take the two lines object. First incident ray parallel to principal axis. After reflection, it is passing through focus from this point F. Clear? Show the arrow. Second incident ray C point is available. So second incident ray passing through center of curvature. So reflect this incident ray and reflected in the same path in opposite direction. Where is intersection occur? So that at that point image is formed. So check the size and position. As compared to size of the object AB, A dash B dash is smaller in size. Smaller in size, there is given one word, diminish. Diminish means smaller in size. Remember, where is the object? Where is the image formed between point C and F? And this is a real and inverted image. All are getting? Next, last position is object at infinite. So show one line. The object at infinite, like looking like star in the sky at night, that is only single point. Answer no, obviously no. That is very very large in size, but that is very far from us, and that's why we are looking like a point source. So we are showing one line. This object is at infinite distance. So the so incident rays are parallel, occur from that far object, infinite object. So we are showing these two incident rays. Both the rays are parallel, so reflection takes place through principal focus. This is the first one. And second incident ray is parallel to the principal axis, so reflection takes place through what? Principal focus. So image is formed at focus. So intersection is a single point, so size of the image is point image, point size image, and really intersection of the reflected rays occur. That's why nature of the image is real and inverted. All getting? And last one already explained. Draw a neat labeled ray diagram of image formation of convex mirror when object placed anywhere in front of convex mirror. So already explanation given here, check that. Object is showing in front of this convex mirror. Show the arrows like this. Same basic concept. Center of the mirror is a pole. At 6 cm take the point C, and exactly half distance point F is there. So first incident is parallel to principal axis. Reflection takes place through the focus. So point. So you labeled here. You draw the dotted line like this way in opposite direction, and in front of forward direction show the dark line. And second incident ray passing through the directly point C, that is center of curvature, in straight line. So A and C directly join. So this is the incident ray up to the mirror shown in dark line. And in same opposite manner reflection takes place. Both the reflected ray divert from each other, so never intersect. So we are extending in a backward direction. So what happened? At the intersection point A dash B dash image is formed. So all are getting. So position of the image is behind the mirror. Size is compare with object AB. So size is by mistake. Size is diminished. Diminished means small in size, and nature is erect and virtual. You change there at the time of writing. Size diminished and nature is erect and virtual. So in this way today we learn. So what we learn today? So image is formed by concave mirror and convex mirror. All of you draw these 7 ray diagrams. Do the practice at home in your notebook and keep your ray diagrams ready for checking in your notebook. Thank you.